Assalamu alaikum, dear students of class 9th of Laurel Bank School System. Today we are going to discuss physics chapter number 9, that is transfer of heat. In this chapter we will discuss how heat transfer occurs in solids. We will discuss the factors affecting the transfer of heat through solid conductors, and then we will be able to define thermal conductivity. We will also discuss convection currents and some examples of heat transfer by convection in our daily life. And we will also discuss the process of radiation, and at the second last we will discuss the factors affecting on rate of energy transfer, and then we will discuss the uses of conductors and insulators. So we are going to discuss the topic number 1, that is the transfer of thermal energy or heat. So when two bodies are at different temperatures and they are in thermal contact with each other, then thermal energy from a hot body will start to flow to a cold body in the form of heat. So this is known as transfer of heat. So basically there are three ways by which heat can be transferred. First method is conduction, then convection, and the last one is radiation. So these are the three processes by which heat can be transferred. So first of all, you can see in the diagram how conduction, convection and radiation occurs. We will explain one by one these topics. So first of all, we will discuss about conduction. So dear students of LPS, conduction is the mode of transfer of heat by vibrating atoms and free electrons in the solids from hot to the cold parts of a body. So this is known as conduction of heat. In the previous slide, you have seen a diagram in which a spoon is there and we are heating at the one end of the spoon, and then we will observe that whole spoon will be heat up after providing heat at the one end, because the transfer of heat is there by the process of conduction, because conduction occurs in solids by vibrating atoms and by using free electrons. So the transfer of heat in solids, especially in metals, takes place by the process of conduction. Now we will take the two methods by which conduction can take place. So first method is by the collision between the neighboring particles and the flow of free electrons. So you can see that there is a high temperature and there is a low temperature at the other end, and heat is started to flow from higher temperature to the lower temperature. So we will observe that in solids, atoms and molecules are packed and close together. So that is why they will continue to vibrate about their mean positions. So when solids heated at one end, the atoms or the molecules will start to collide with the neighboring atoms or molecules. So in doing so, they pass some of their energy to the neighboring atoms or the molecules during the collisions with them, with the increase in their vibrations. So these atoms or molecules in turn pass one part of their energy to their neighboring particles. So in this way, heat will reach at the other part of the solid, but this is a slow process and very small amount of heat is transferred from hot to the cold parts in the solids. And the second method by which conduction occurs is the flow of free electrons. So electrons that are quite near to the heat source will gain energy, heat energy, and then it will start to move faster. So free electrons can move between the particles and they will collide with the other electrons, and this allow the less energetic electrons to gain energy, and they will start to move faster, and this process will continue to spread the heat to the cooler parts. So this is a process of conduction, and conduction can mostly takes place in solids, but it can also occur in liquid and gases. But as you know that the particles or atoms or molecules of liquids or gases are quite apart from each other, so collisions between them are less frequent as compared to the solids. So conduction of heat through liquids and gases is very much slower as compared to solids. Now come towards the next topic, that is the rate of flow of heat. So I am going to tell you what is meant by rate of flow of heat. Then after that we will discuss about the topic of thermal conductivity. So first of all, the amount of heat that flows in unit time is called the rate of flow of heat. So rate of flow of heat can be written in mathematical form as rate of flow of heat is equals to Q over T. Q represents basically the heat and T is time. Heat energy divided by time, so it is rate of flow of heat. The rate at which heat flows through a solid object depends on various factors. So in order to find out the factors, we have to consider a solid box of having two opposite faces, each of cross-sectional area A, and it is heated with temperature T, and then heat Q will start to flow along its length to the opposite face at the temperature that is lower than the temperature on which heat is providing. So factors that are affecting on the rate of flow of heat is the first factor that we are going to discuss is the cross-sectional area of a solid. So cross-sectional area of the solid, larger the cross-sectional area, greater will be the rate of flow of heat. So rate of flow of heat is directly proportional to the area. Now come towards the second factor, that is the length of a solid. So length of a solid is inversely proportional to the rate of flow of heat. So its mean is that greater will be the length, then smaller will be the rate of flow of heat. And the reverse process is there, that is larger is the length, then smaller will be the rate of flow of heat, and larger the length, then smaller will be the rate of flow of heat, and smaller the length, then larger will be the rate of flow of heat. What is the reason? Because due to the increase in length, it will require more time to reach the heat at the other end. Now come towards the third factor, that is temperature difference between the ends. So you can see that greater the temperature difference from the hot to the cold part, greater will be the rate of flow of heat. So rate of flow of heat is also directly proportional to the difference in the temperatures between the two ends. Now you can see that what we have to do, we have to combine these three relations in which cross-sectional area, temperature difference and length is there. So rate of flow of heat is directly proportional to area and the temperature difference, while inversely proportional to the length of a solid. So whenever we will remove the sign of proportionality with the sign of equality, then there is a constant value, that is K. So K is known as thermal conductivity. So how we can define K? So K can be defined as the rate of flow of heat across the opposite faces of the meter cube of a substance that is maintained at the temperature difference of 1 Kelvin. So this is known as thermal conductivity of that substance. So unit of K can be easily calculated, that is watt per meter per Kelvin. So those materials of different objects have different value of K, and larger the value of K, then they are considered as good conductors, while the materials having the less value of K are known as insulators. So dear students, this is the concept of thermal conductivity. Now we will move towards the topic of convection. So convection basically mostly takes place in gases and liquids. So convection can be defined as the transfer of heat by the actual movement of molecules from hot place to a cold place. So this process is known as convection. So the main mechanism of the convection is just the change in the density of liquid. So you can see that a liquid or gas that become lighter, they are less dense as they expand on heating. So hot liquid or gas rises up above the heated area, and the colder liquid or the gas from the surroundings fill the place, which in turn is heated up. So in this way all the liquid is heated up, so therefore transfer of heat through liquid takes place by the actual movement of molecules. So we will discuss the phenomena or the mechanism of action of convection. So fluid that is nearer to the heat will gain more heat and they will start to expand, and due to expansion there is decrease in the density of the liquid that is quite near to the heat source. So it will start to rise because it has less density, and the hotter liquid rises over the cooler one, and the cooler liquid will rushes into to take the space basically, and then the process will start and a convection current is formed. And convection is basically faster than conduction because there are a lot of movements of the molecules, and all the molecules basically get hot and they will start to move, and thus we can say that convection is much faster than conduction. Now we will observe that how convection currents can be produced. So convection currents simply can be produced by heating the substance by using heating elements at the bottom. Then they will gain obviously the heat energy, and after that they will start to rise up, and the cooler one start to move down because it is quite large density as compared to the hotter object. So that is why we will see that cooling elements are mostly placed at the bottom, and hotter air will start to rise and the cooler one will start to move down. So this process is very important, and we will discuss these phenomena. We can see that in electric kettle the same phenomena is used. The heating element is placed at the bottom, so the liquid will gain more energy, heat energy, and it will start to rise, and the other liquid will start to move in the downward direction, which has more density as compared to the water one. Now we will observe that what are the uses of convection. So first use that I am going to tell you is the sea breeze and the land breeze. So sea breezes and land breezes are the result of convections and convection currents. So we can observe that on a hot day the temperature on the land increases more quickly than sea. So it is because the specific heat of the land is much smaller as compared to the water. So the air above the land gets hot and it will start to rise up, and cold air from the sea begin to move towards the land. So it is known as sea breeze. Now I am going to tell you the land breeze. So at night the land cools faster than the sea. So air above the sea is warmer and it will rises up, and the cold air from the land begin to move towards the sea. So it is called land breeze. And the other use that I am going to tell you is the gliding. And glider basically look like a small aeroplane without engine, and they will also use convection thermals. Now I am going to tell you about radiations. So radiation is the third method by which heat can be transferred from one place to another place. But in this case, we will observe that the heat will be transferred from one place to another place in the form of waves that are known as electromagnetic waves. And radiations basically acts in all directions, and the object that is a good emitter of radiation is also a good absorber of radiation. And our sun is the major source of heat energy, and heat transfer from sun to the earth in the form of radiations, because there is a space between sun and earth, so which does not allow the heat to transfer either by conduction or convection. So radiation is very important for us because sun is the major source of heat energy that is providing heat to the earth. Now we are going to discuss the factors that affect on the rate of radiation. So there are several factors which affect the emission or absorption of radiations of an object. So first factor is the temperature of object. So higher the temperature and more the radiation it emits. And second factor is the surface of the object. So if dark and dull surfaces are there, then they are considered as good radiator of radiations. And the third factor that we are going to discuss is the surface area of the object. So objects with larger surface area will emit infrared radiations at higher rate. So its mean is that larger surface area objects will emit more radiations as compared to the smaller surface area. Now we are going to discuss applications of thermal heat transfer, in which we will discuss about good conductors of heat and bad conductors of heat. So good conductors are mostly used when thermal energy has to be transferred quickly through a substance. Like we have to use cooking utensils in kitchens. So kettles and saucepans are usually made of metal where direct heating is involved. While if we want to minimize the loss of thermal energy, then we have to use bad conductor of heat. So handles of appliances and like utensils like saucepans and kettles, teapot handles are made of plastic to ensure that we have to carry the appliance without scalding our hands. So this is the difference between good conductors and bad conductors applications in case of thermal heat transfer. Now I am going to assign you the homework. First of all, you have to memorize whole chapter according to SMART syllabus. And in this chapter you have to cover, you have to memorize the topics: transfer of heat, conduction, convection, uses of convections, radiations, as well as you have to memorize the uses of conductors and insulators. And after that I am going to assign you a homework in which you have to do question number 9.1, part number 2, 6, 7, 8 part number that is given on page number 207, and the date of submission that I am going to announce is 24th of December. And the spelling test number 22 of chapter 9 will also be held on 24th of December. And if there is any query related to this chapter, then you can ask in your related groups. Thank you.